So, uh, how to interpret some of the function notation things we talked about last time from looking at a graph. You have to remember that when I say f of x equals some formula or something like that, y is taking the place of f of x. So basically, the y coordinate is a function of x. So x would be a domain value. It's just any value that is able to work with the function. And the y value would be the result of you plugging it into the function, figuring out what that value would be, and that would become your y coordinate. So when you see them say, okay, what is f of 2 given a graph of y equals f of x, it's actually asking you for the y coordinate when x is 2. So when I look at doing so here, I can clearly see that, here when x is 2, y is also 2. And when it asks for what is the value of what is f of 0, well, that's again asking, okay, what is the value of y when x is 0? Well, here's where x is 0, and there's where the function is, so it looks like it would be at negative 3, and that's what it is. F of 7, pretty straightforward here. Here's where x is 7, so I look to see where the y coordinate is, and there it is up here at 1, so I would say 1. Now, they could ask about other points that are on this graph that may cause a little bit more confusion on that end. They could easily ask, like f of 2, when you looked at that particular question, well, why did I choose 2 rather than down here at negative 2? Well, it kind of goes back to that open dot idea. The open dot here represents a hole. So this is a hole. This is an actual point that's on the graph. Therefore, it's the value of 2 I'm looking for, not the value of negative 2. What is the domain of f of x? Well, I'm looking to see how far left and right my x values go. And I'll also want to keep in mind if there's any gaps going along with that. So what I tend to do is something along the lines of this. First of all, I look to see I start at negative 4. I move all the way to the right here until I get to 2. Following this path on here. I have an open dot there, but I do have that closed dot up here. And so if I continue on from there, I have x values going from 2, 3, 4, 5, all the way to 6. Then I have a jump down here, open dot there, but I still have that closed dot above it, so it is defined for x being 6. And then x goes through all the way up through 8, excluding 8 itself. So so that's the only thing I have to make sure that I exclude, and that's why I have a bracket at negative 4, and I have a parenthesis at 8. Some students will sometimes look and find and see gaps in this. It's very rare that you're given a situation where you have gaps in your domain. Gaps in your range, on the other hand, are very typical. Because if you look here really carefully, much like the domain, the range, I'm going to see where the y values go from. So looking how far down I go for a graph, how far up I go, what's its maximum point, and are there any y values that are basically undefined? What I've shaded here is, these are areas where I have this graph in red occupying a y value. So I have some between negative 5 and negative 2. I have the value of y being 1, and I have values between 2 and 4 for y values. But I also have gaps in between. So in a lot of instances, you may in fact have gaps in your range. You're not going to see many instances where you're given functions that have gaps in your domain. Although we'll see them as we move along with specialized, like rational functions and things like that, where there would be a reason to have a gap, but we have specific ways of finding those specifically. So if I look at the range values here, I go down as far as negative 5 up to negative 2, not including negative 2. I have a gap until I get the y value of 1. I have several x values that have a y value of 1. Even though I have open circles at the two ends, like for instance at x equaling 7, we have a y value of 1. So that tells me that 1 is in the range. Okay, I don't want to exclude that. And then when I go to the last part, I have a gap between 1 and 2 at 2 through 4 y values, I have, y values that take up those values. So I'd represent it like this, going from -5, which I include, to -2, which I don't. A union symbol, I use set notation and put the number 1 there because I'm just listing a single value. There's no other values in that portion that's that y value of 1. I don't like 1.001 doesn't count, 1 or 0.999 doesn't count because those values are actually in those non-shaded regions on the graph I have right there. Um, and then I go from 2 to 4, equaling both values. I do have a y value. The graph clearly goes up to 4 here. So those are my y values.